Hello, my name is Alberto Rodriguez, and my presentation is about forecasting prices while overcoming uncertainty. To begin, I want to give you a little background. I decided to do the M5 forecasting based on uncertainty, which is the forecasting of sale prices for various products sold at Walmart. And this is found on the Kaggle website. One thing that I found and that had a lot of it was gonna have the explanatory variables, which was gonna make the forecasting a little more complex. But I decided to take it one step at a time, and I just wanna go over some of the things that I did for this project. My motivation for this project was to be able to forecast uncertainty during uncertain times like we are going through right now. Specifically, some of the items that we see in supermarkets that are on high demand, like soap, toilet paper, and even meat. In some cases, it's really hard to find any beef or any chicken, and it comes on and off. So I wanted to be able to find something, a way to forecast what the prices will be when these items will be on high demand. I also wanted to test different techniques that we have learned throughout the semester, and also have the satisfaction to see that a forecasting tool could work. And I want to talk about the methods that I thought. I thought that I could try some of the previous methods that are recommended on the website. I'll show you some of those. Some of the approaches here, but one thing that got my attention is mentioning SVMs, support vector machines, because we mentioned this in class, and I had worked with this recently, and so I wanted to give that a try, as well as to see if I can use other methods. Maybe I thought about Markov decision process that I can utilize in there. And so, like I mentioned, I had, as far as other related works, I had worked with SVMs during this side project that I was learning about for a salary forecast. Let me show you and walk you through it. So this is it. It's a small database data set here, and what it shows is the different levels of individuals and what salary they're expected to have, and based on that we should be able to tell any of these levels. However, one of the problems that I faced at the beginning, at least based on the way how this code works, I'm using Spider here, but the code is all Python, is the plot. And what the plot, the 10 points that you see here in red, those are all these points here from the data set. And the blue line is a forecast, and as you can see, it's pretty accurate, except for the last one, which is the CEO. So it could easily be considered an outlier. But for all the other points, it comes pretty close. So I thought I could use something like this. However, one thing that I was not being able to figure out is this scale right here. You will think that the first scale will be here for 45,000 and 50,000 and 60,000 and so on. But instead it created this scale right here. So if you want to know how much someone will do on like the 6th level, then you will have to input this number here to kind of guesstimate how much this salary will be. And so, for example, let me show you here. I was doing this one example with 0.8, which will be around 0.8, this point right here, which is the 8th level, which should be around $300,000. And the prediction is pretty close, $302,000. So that's not bad. But you have to be able to put the amount that you want to predict in terms of this scale right here. So if you want to predict like this 7th level right here, you'll be close to 0.5, although it seems like it's a little bit more. So I'm going to try 0.55. And I'm going to run it and see what the prediction tells me. The prediction tells me around 217 for level 7. So that's kind of close. So let me see if maybe at 0.5 it works a little bit better. It works a little bit better at 0.5 actually. It's pretty close to 203,000. Say for instance, if we were trying to do around this, the 4th level. For the 4th level, which is $80,000, so it will be negative 0.5. I will run the code and check the prediction, and it's pretty close. 100. Oh, I'm sorry. Maybe I meant the 5th one. 1, 2, 3, 4. 1, 2, 3, 4. So about 80,000, maybe. And that's the problem that I was having, that it's not precise. So I guess it's a little bit less than 0.5. So I don't know, 55. Let's see what that tells me. Yeah, it's still around the 100,000. But just the fact that the prediction seems pretty close, I thought this is something that I could use. And that's what I was working on. I decided to work something similar on Python using Jupyter here instead. And while running the code, it came close to this. So I kind of liked it. It looked kind of good. Except for like these outliers. And what I did is, because the original data set was too large, I broke it down into items that Walmart sells. And so these are the prices, and these are based on the year. The year will be here, those 2 digits, 13, so that's 2013, and this is for week 25 of that particular year. And so one of the biggest problems that I was having at the beginning was that I was trying to make my prediction based on that number. So I thought to myself, I want to predict, say, let me take a quick look again. Let's say I want to predict week, let me see an easy number to remember, 11/4/30, which is 2014, the 30th week. And let me show you. This is what I was constantly getting. Here's the prediction. But if I try that, I was constantly getting like something higher. It's like not that off from the original price, which is supposed to be able to forecast 8.26. But I kept getting this, and no matter what week I will put in here, it will not come close to what it's supposed to be. And then I realized the scale. That's what was getting my numbers off. And so after realizing that, I realized, well, what if I want to do somewhere around in the middle? I want to predict a price somewhere around the middle. Let's say 0. So if I switch this to 0, then the prediction is much better, 8.27, compared to the actual price is 8.26. So that's not bad. And then I wanted to do some more tests to see if something changes on this data, would the forecast also be good in that sense. And so what I tried to do was just kind of change a bunch of these prices somewhere like in the middle. Like say I want to change this to like, let me see, so what's somewhere in the middle around here. Let's say I want to change this to like, let's say the price went up during this time to 850. Let's say 852, 851. Okay, and then a whole bunch of these during this time went up to 851. And I'm gonna save and I'm gonna run the whole thing again. And so what you see is here the price hike, goes up, but the forecast doesn't adjust all that much. Remember how it used to be a straight line? It just slightly goes up. So it definitely needs some work. But this goes up to 8.31 again. Let me take a look to see where am I. Yeah, I will be somewhere around here. So the prediction goes through here. It doesn't try to deviate so much from. It kind of treats them like outliers, and the prediction tries to stay more along the lines of what most of the other prices are. I will think that if I change even more prices, then that's what makes the biggest difference. Let's say I do this and save it and then try to run it again. I think this might make a difference. And this is the first time that I'm ever doing anything like this, and just the fact, look, because it must have, and this is what I still, for my future ways of improving the code, is there has to be a threshold at which point the code decides to really curve when there is a large number of certain prices. But for a first try, I was very, very impressed. So if I want to go around that area, negative 0.5, I want to predict what's the price around there. If I run it, oh yeah, 8.52. That is pretty good for what I changed to 8.51. So the forecast, it does try to adapt, but if there are few outliers like these ones, it will kind of ignore it. So it will go for what is. There has to be a number, and I'm not sure what that number will be. But if the price changes, say for more than 20 weeks in a row, then it's gonna follow it. But if it's less than that, it might not. And so that's what I started working with. And I mean, it seems simple of how far I made it, but up to that point, I had really been struggling. So in my analysis, like I said, initially the forecast seemed static because I kept getting the same amount, 8.31. And I also try to implement markup decision process, but it became kind of difficult. This is what I was trying to do. I was trying to come up with something that I can implement when um, it could learn that it's getting close to the actual price. Because at the beginning I thought that the SVR will not work the way that I thought, because I was having so much trouble until I figured out what I was doing wrong. But then after I went back and going back and forth, I figured out that it's a pretty good predictor, and maybe I can use other tools in the future to make it even better. And that's pretty much everything that I did. Here are some references and my data source that came from Kaggle. I hope you found it interesting and inspiring, and it's definitely inspired me to keep trying to make better forecasts in the future. Thank you.